Hello everyone, this is Yasmeen Abdrabou, and on behalf of my co-authors, I am honored to present to you our paper, Your Eyes Tell You Have Used This Password Before, Identifying Password Reuse from Gaze and Keystroke Dynamics.
Across decades, passwords remained the ubiquitous authentication technique. With the increased number of websites and the need to register on them, users tend to have an average of 80 accounts, and hence users started reusing passwords. A recent Google survey showed that 65% of the users reuse passwords. Another research showed that on average, a single user has 6.5 passwords shared across 3.9 accounts. This puts the users under the threat of a single point of failure, as if one password is leaked, an attacker can access different accounts. Therefore, we propose a novel approach of detecting password reuse by leveraging eye gaze and typing behavior, and study its accuracy using machine learning classifiers. This was motivated by our prior work on using gaze behavior to detect password strength, and also from literature where keystroke dynamics showed potential in detecting password reuse. For the evaluation, and in order to investigate our approach, we implemented a repeated measures within subject's design, where we asked the participants to register on two websites with different content sensitivity. One, the university email web page, and two, a popular news website. The order of the interfaces was counterbalanced on a Latin square. We also had different dependent variables such as the study duration, eye gaze matrices, keystroke dynamics, and password characteristics. We did not store users' passwords, however, we stored the characteristics for each placeholder, whether it was a lowercase, uppercase, number, or a symbol. For the apparatus, we used a Lenovo Yoga laptop with a TUI 4C eye tracker. We recruited 52 participants with 10 females. The age varied between 17 and 54 years old with a mean of 25. Participants did not have experience with IT security and almost half of them had glasses on. We set up a booth in a quiet area in the university's cafeteria. We approached people on campus and asked them to participate in the study. Here, I will refer you to the paper for more information on the study design considerations. For the study procedure, first, we told the participants that our aim is to enhance the user interface's usability, and that's why we are using an eye tracker. Then, we asked them to fill in the consent and demographics form. After that, we calibrated the eye tracker and asked them to register on the websites. After each registration, we asked them to mark the memorability of the password on a scale from 1 to 5 and then log in into each of the interfaces. Finally, participants were asked to fill in a post-study questionnaire reflecting on their strategies of password creation and also whether they reused the password or created a new one. For the results, we found from our post-study questionnaire analysis that participants entered 14 reused passwords on the email client. However, this number was a bit higher for the news website. We can also see that reusing passwords affected significantly the duration of password creation. After that, we analyzed participants' behavior and password characteristics. We found that participants entered similar length and characteristics in terms of the number of digits, symbols, lowercase and uppercase letters for both the reuse and new passwords across the different interfaces. We also found statistical significant differences for the keystroke dynamics between the new and reused passwords across the different interfaces. For example, the time between entering the consecutive characters and the thinking time before participants type their identification was longer for the newly created passwords. We also found statistical significant differences for the gaze behavior between the new and reused passwords across the different interfaces. For example, participants had more and longer fixations when creating new passwords compared to when reusing passwords. Please refer to the paper for more details. For this, we implemented two different classifiers, namely interface dependent and interface independent. We created the interface independent classifier to investigate the generalizability of our approach across the different interfaces. We compared between three different classifiers, namely SVM, random forest, and decision trees. However, random forest gave the better results. Before we ran the classifiers, we decomposed the password registration process into 4 phases. The first phase is the orientation phase. It starts when the user opens the interface until the first letter in the identification field is written. The second phase is the identification phase, which starts when the user enters the first letter in the identification field until the cursor moves to the next field. The third phase is the password phase. It starts with the first letter entered in the password field until the cursor moves to the password confirmation field. Finally, the password confirmation phase. It starts when the user enters the first letter in the password re-entry field until they click on the register button. We computed both the area under the curve and the accuracy. However, the area under the curve gave better results. For the interface-dependent classifier, here we can see the accuracy per each phase and for all interfaces. We found that gaze features had higher accuracy, around 7% higher compared to keystroke dynamics for all phases. We also can see similar classification accuracy for both interfaces. However, the accuracy was a bit higher for the email client. We can also see that gaze data can be retrieved from the beginning of the registration process, unlike keystroke dynamics where it only starts with the first letter being entered. This highlights the strength of the gaze behavior as it takes into consideration the orientation phase where we believe that most users choose their password and strategy in. For the interface-independent classifier, we found that gaze features gave better results compared to keystroke dynamics. However, the difference has reduced to only 4% enhancement compared to the interface-independent model, which means that building interface-dependent classifier or even classifier per website category will enhance the classification accuracy. We also computed the classification accuracy cumulatively for the multiple phases. From the figure, we can see that the best classification accuracy is achieved after the identification phase for both interfaces. This might indicate that by then, users have already made their decision on which password to use, and the accuracy stays almost the same over time. We can also see that gaze features gave better accuracy than keystroke dynamics. Our findings show that by using gaze, we can nudge users not to reuse passwords even before they type the password. This can save users this time, as users are less willingly to change their created password in a later stage. To conclude, we proposed a novel approach of using gaze behavior and keystroke dynamics to detect password reuse. We found that gaze is more informative than typing, especially that gaze data is available for the full registration duration. However, keystroke dynamics are only available when users start typing. We also found that the website data sensitivity influences the accuracy of the predictions, as we saw that the email classification accuracy was higher than the news web page. Finally, we found that splitting the registration process into phases and study each phase separately or even combined phases enriches the classification prediction and gives better understanding of the overall process. Thank you so much for your attention.